Hello everyone. Today we are going to discuss Codeforces round 895 div 3 A to G problems. I'll be telling you their solutions. So this is the first problem, two vessels. In this there are two vessels which have like A and B grams of water in them respectively. Like one vessel has A grams and the second vessel has B grams. And we also have an empty cup which can hold up to C grams of water. So in one move, we can scoop up C grams of water from any one of the vessel and pour it into the other vessel. So we want to calculate, yeah, and one more thing, like the amount of water in the vessel can be any number less than equal to C. It can be a non-integer also. So we want to know what is the minimum number of moves required to make the masses of the water equal. So obviously, if like given one of the vessel has A gram of water and the other has B. So the thing is, what we'll be doing is we would try to make them equal. So if consider like some known example like something like this. Let us consider 3 comma 7, right? So for 3 comma 7, if we do here, so consider 3 and 7. So what can we do? We need to shift the water, right? So we will shift the water from 7 to 3. So we have to make them both equal to 5. Like our target is 5 because it is the midpoint. So basically, what is the midpoint? A plus B by 2. Uh, yeah, it's A plus B by 2 is our midpoint. So we have to make them equal to this. So how can we make it equal to this? If we can basically, how much water do we need to shift? We need to shift 7 minus 3 by 2, because if I shift half the difference of the water, they both become equal. So in general, what is the formula? B minus A by 2. This much water we have to shift. So so basically we can shift at most C grams of water in one move. So we can take seal of this upon C, right? We can simply take seal of B minus A by 2 and C uh, from C. So this would be the answer, right? Like if we consider for 7 and 3, so 7 minus 3 is 4 and 4 by 2 is 2, right? So what can we do is 2 seal of 2 by 2 is 1, if you see. And the seal of 13 by 3 is 5. Sorry, 13 by 2 is 6 and wait a minute. Yeah. Actually, if you see, we have to shift 7 minus 3 by 2. This is something that we have to shift uh, because we can shift at most C grams of water. But what is, if we look in the different direction, what is the maximum amount of shift we can do rather than doing 7 minus 3 by 2? If we see, we can basically change the difference by 2 into C in one move, right? Like 2 into C. This is the change we can make in one move. So basically, let the difference be 7 minus 3 only. Why I am doing this? Because it would make it double. Basically, it could be some zero point 0.5 something. So we don't want to complicate things. So what we can do is we can take the difference as 2 into C. So what we can do is we can take seal of B minus A. Seal B minus A 2C. Seal is not, yeah. Seal, yeah, B minus A by 2C. This is the seal we have to take, and this is the answer to this question simply. So you can see this, this is how it would work. So yeah, so this is the answer to this question. Now I'll move on to the next one. So yeah, so this is the new problem. Let's move on to the question B. So a corridor is given, and there are some traps in the corridor. The corridor length is infinite. So a trap has some property. Like trap is located in. Firstly, the person is in room one, I guess. Yeah. So trap is located in room D, and it has activation time s seconds. It means that after s seconds, you can't basically go through that room. Like there are some traps. So a trap would have. Uh, minute. Yeah. So a trap has a property like this. It has a D and it has an S. These are the two properties of a trap. So what happens after if say the D is equal to 4 and S is equal to 3. So when the person goes through D, after 3 seconds, the trap would activate. It means that if at T equal to 4, the person passes through this trap, for T greater than equal to 7, he can't pass through this trap. And also like yeah also the person takes 1 second to pass through each room. So initially the person is at room 1. So some n number of traps are given. We want to find the maximum possible maximum number of the room person can go to and return to back to the room number 1. It means that the person has to return to room number 1. It also means that he shouldn't be caught by any activity trap. So what we can do is for each trap we can calculate the maximum length the person can go to. What could be the maximum length a person can go to for a particular trap? So let's say a person for time t is at some trap at the room number D. What happens is he can still what he can do is he can go to some room number X and he can return to room number D. The time for this should let us consider the time here is C and the time here is C, and T plus 2C should be less than S. This is the condition, right? So we want to calculate what is the maximum X for this, and X is totally dependent on C, right? So basically C is X minus D. So if we see T plus 2 into X minus D should be less than S. So what we can do is, basically we don't know the current time, and we don't even need the current time. Basically, T is zero here because at for after a seconds from T, the trap like is activated, right? Basically, it is S plus T. My bad. So the trap would be activated after S seconds of T, right? T plus S. So we can cut this T, and X minus D is less than S by 2. Yeah. So X is less than S by 2 plus D. So the maximum X would be uh, S by 2 plus D minus 1, I guess. But you have to take it actually it depends on S. If S is even, it would be like, so what I can do, I can take the floor, I guess. What I can do, I can take the floor division if S is odd, and if S is even, I can take like I can do minus put another minus 1 here. So it basically depends on S here, because we want to make it less than it, right? So if S is even, I can cut off this minus 1, and if S is odd, then I can do this. And this is floor, basically floor of S plus floor of S plus 1 by 2 plus T, something like this. So like if I visit the solution of the problem, I have done something like this. So I'll take minimum of among all the traps, minimum of this among all the traps. That would be would be the maximum of it. So my solution, if you can see, it is something like this: a plus b minus 1 by 2. So b is basically what I have done here. So b is basically s here. So s minus 1 by 2. Yeah. Basically, I have taken out the minus one, and this is uh, yeah, b minus one. Actually, yeah. So if you see here, why is it b minus 1 by 2? Let's see. So at least yeah. So I can take it as s minus 1, the maximum time, right? It is equal to s minus 1. Here, if I see, like, I should remove all this. Wait a minute. Yeah. So what I can do is, like it was like this, na. 2 into x minus d is less than uh, s, right? So x minus d is equal to s minus 1. 2 into minus d. I can do this. So what I can do is s minus 1 by 2 plus t. So this is obviously floor because this can't be a double. It has to be an integer. So this is the answer. Yeah. So this is the solution. I have to take minimum across all the traps, and this is the solution for this question. Let me erase all this. Yeah. So we'll move on to the next one. Non-coprime split. So basically, in this question, there is an L given and an R given. I have to find a pair of numbers so that a plus b is greater than equal to L and less than equal to R, and the GCD of those numbers is not equal to 1. Like basically, a number a and b are given. So a plus b should be greater than equal to L and less than equal to R, right? And GCD of a comma b should not be equal to 1. Let me look at the constraints. So if I look at the constraints, test cases are less than equal to 500, and L and R are less than equal to 10 to the power 7. Okay. So, like what I can think of an approach where, like, you can see that the pair of even integers are always non-co-prime, right? So, if I take the range L to R, so what would be the first number so that I can get some a comma b so that they are non-coprime? Actually, it is quite easy. The thing is, what we can do is, like if we see this x is an even number, and I can take another number, another even number which is just adjacent to it, x plus 2. So 2 into x plus 2 is the number. So 2 into x plus 2 should be in between it should be in between L and R. So if such a number is present, then where x is even, then I can easily find a pair of numbers so that they are non-coprime. So if you can see, for x to be even, what is the frequency that I can find? Like basically, what is the property of this number? So basically, it is x mod 4 plus 2. X is sorry, I can take it as y. Such a number is always has a pair of numbers so that it sums up to that number, and it is basically the numbers are coprime, which form the sum. So for this number to be in L to R, it is true that L minus R should be greater than equal to 4, right? If this is true, then such a number is always there. So it means that if r minus l is greater than equal to 4, I can easily find a number. So what if I check from L to L plus 3? In these four numbers, I can easily find in this range, I can easily find well, one of these numbers has to satisfy this condition, right? One of these numbers. So there are only four numbers that I have to check. So what I can do for that, I can check all the factors of this number, and after seeing after when I basically for each number I check if it is prime or not. Basically I check all the factors, and after dividing it by that factor, if the number is basically greater than equal to 2. Why I'm doing this? Take for a particular number y is divisible by some number k. Y modulo k is equal to 0. Let us consider this, right? So it means that y by k, sorry, yeah. Um, so if y is divisible by k, so if I take y by k, and if I divide y by k into some number of sum, let me take one of them as 1 and one of them as y by k minus 1. If I take these two numbers and I multiply both by k, so for these numbers, they are not co-prime. That is true, and they sum up to this number y. So for a particular number y, I've got a number, like I've got a pair which is co-prime. If it is divisible by k, and one more condition is there, the number should be positive, right? To be co-prime, number should be positive. So what I can do is like for these to be positive, y by k minus 1 should be greater than equal to 2. Sorry, should be greater than equal to 1. It means that y by k should be greater than equal to 2, right? Y by k is greater than equal to 2, right? So I just have to do that for all these max to max. I have to check four numbers, right? So all these four numbers, I check all the factors and I see for some number, is it true that for a particular factor y by k is greater than equal to 2? If this is true, then my work is done and I have found a pair, right? So yeah, it means that I have found a pair. So like this is the algorithm for it. I can show you my solution, and this is the answer. And this is well within the time limits because the numbers are ranging from 1 to 10 raised to power 7. So max to max 10 raised to power 3 iteration per test case. 10 raised to power 3 into 4, you can say. So what I've done, I have just iterated from a plus 3 to b, and b are basically l and r. So yeah, I check each of the factor, and if one of them is greater than 1, I just basically I change the range. I change the numbers accordingly. So if I find no number, I just print minus 1. So let us move on to the next question, which is the third one. Sorry, fourth one. Plus minus permutation. So this question, in this question, we have a permutation of numbers. We can form a permutation of numbers of length n. Now, what is given is we have to do the following. There is a number given x and there is a number given y. So I have for every multiple of x, uh, those positions should be added in the permutation, and for every multiple of y, those positions should be subtracted in the permutation. So for that, I should erase. Yeah, so consider that what is happening is for a number n, a permutation of n numbers is there, and there is no, a number x and a number y. So that p of x plus p of 2 into x, something like this, goes on till less than equal to n, and we have to subtract p of y, p of 2 into y, something like this. So if you notice, the common numbers, common positions don't matter. What matters is the unique positions in both of them. So if the unique positions in X are the, if I take them to be the greedily maximum numbers, n minus 1, something like that, and I take for Y positions which are unique, I take something like 1, 2, 3, 4, 5, then I would get the maximum, right? So I just have to calculate how many unique positions for X and how many unique positions for Y. So if I have to calculate how many positions for X, so it is n by X, right? And how many positions for Y? N by Y. What are the common positions between X and Y? Basically, it should be n by LCM of X comma Y, right? Least common multiple of X comma Y. I can easily calculate it by X into Y upon GCD X comma Y. So these are the common numbers. This is what is present in Y. This is what is present in X. So to get the unique numbers which are there for X, I can just subtract this number. Let it be K. So n by X minus K. So these are the numbers that should be the maximum ones. N by X minus K. And these are the numbers which should be the minimum ones. So how to calculate the sum of all these numbers? This is very simple. Like if you know the formula, n into n plus 1 by 2, right? So basically, I am starting from the maximum. So if I take all the numbers from n into n plus 1 by 1 to n, what is the sum of them? N into n minus 1, n into n plus 1 by 2. And the thing is, I have to subtract basically what are the numbers? If you see, they are n minus 1 till n minus uh, n minus x plus k. uh, this number is not there. Before that, all the numbers are there. Something like this. This is the range. So in order to calculate the sum of this, I can just take the sum of 1 to n and subtract the sum of 1 to this number. So what I can do is n into n minus 1 minus n minus n by x plus k into n minus n by x plus k plus 1 upon 2. And I have to subtract the numbers in y also, right? So for y it is simply n by y minus k into n by y minus k plus 1 by 2. So this is a simple formula for this question. So I can show you my solution. So this is the solution. I just taken the LCM. My LCM is R basically. So yeah, so it is n by R. Uh, yeah. So basically this is the same formula as this one. Here K, yeah, that is right. So I'll move on to the next question. Before that, I'll erase it. Yeah. So what does this question say? There are n animals from 1 to n, and something is there like yeah, and there all the animals have some price, and they have a number ai, which is the number of the element they are afraid of, number of the animal they are afraid of. And there is the something like uh, if an animal which if a particular animal is afraid of another animal, and the animal which is afraid of the other animal is sold before the animal it is afraid of, the price of the selling price of it doubles. So we want to maximize the selling price of the all the animals. We have to choose an order to sell the animals. We have to choose some permutation basically, because the animals are numbered from 1 to n. So if we can choose some order so that the we can get the maximum selling price, we have to print that order. So how are we going to do that? Of course, like the basic approach seems like we have to use a graph. Of course, we have to use a graph here. And like if I can create a graph like this, something like this, I can create an edge between there is an I and A of I. I can create an edge between this, something like this kind of edge. So I can create a graph, and obviously the animal which comes before should be like should be sold before. So this looks something like topological order, right? Topological sort. But the problem is that it might not be like might not be a directed acyclic graph. That's the main problem. But can we reduce it to if we basically what can happen here? Like every element, every like vertex can't have more than one edge. So it means that it can have maximum of like it can have a cycle, and basically it can have a simple cycle max to max. It can have many simple cycles max to max. Either it is a DAG, and if I remove the part, the DAG part, the cyclic part is basically a full circle, full cycle, where like the elements are. It is not a full cycle, my bad. It is a simple cycle where the elements are connected to each other in a cycle. So it means that if I can, if like the algorithm we follow in to calculate the topological sort, we basically first of all remove the elements which have zero in edges. Basic in edges means that if an edge is pointed to a vertex, so where there are zero in edges, it means that no edge points to them. We start with them. We put them in a queue. Uh, yeah, we put the elements in a queue where in edges is equal to zero. We first of all put the elements like this only. Like we start putting elements. We create a vector x, and we start putting the elements which have in edges zero. After that, we use BFS. Like we run a BFS where we what we do is the thing is we remove the vertices one by one. The vertices which have in edges equal to zero, we remove them. Remove these vertices, and removing these vertices, basically uh, uh, all the vertices, the vertices that a particular vertex points to, uh, also basically the in edge of that vertex also decreases. So in edge of a of I, a of j, like take some other index, in edge of a of j decreases by 1. So it means that if this now this basically for this vertex, if in edge is 0, I can push it into the queue. Q dot push j. So it means that I can keep pushing on elements till it happens that either all the vertices are 0, sorry, all the vertices have in edges as 0, or all the vertices have in edges as non-zero. The vertices which have in edges as non-zero, it means that they are in a cycle, and they might be in cycle with some of the elements. So there can be many cycles also. After doing this, I have some elements in the vector x. X is basically the order we want. It is the final vector only for answer. Now, for cycles, how would we handle it? We can apply DFS. After applying DFS, basically we need a order. Basically, it would happen that some of the vertex would be like that. Like it would be for some I, so that A of I comes before that. A of I comes before I. It would happen for one vertex. For others, I can do that. Like I can basically spread out the cycle. If consider that cycle is something like this, 1, 2, 3, 4, something like this. So what I can do is, it is a directed cycle, obviously. So what I can do is, I can start with 2, 3, 4. The thing is, 2 comes for 3. Basically, the element which it starts from, like yeah, 3 comes after 2. So 2 would have the full cost, basically double the cost. 4 comes after 3, so 3 would also have the double cost. 4 comes before 1, so it has the double cost. Now 1 comes after 2, so it wouldn't have the double cost, it would have single cost. So in the whole cycle there would be one element remaining, like after who comes after the animal it is afraid of. So I have to select the minimum cost among that cycle, and I have to put that element in the last, and I have to go order by order. So what can I do in a DFS? I can find which is the minimum index, and I can again run the DFS basically to know the order in which the elements are. So I can start the DFS from the number which is the minimum, and what I can do is I can put this in the last, and I can start from the next element in that DFS. So I can either store it or store them in a vector. I can use DFS, or I can do use BFS. Anyway, I will find the perfect order for it. The main problem was this only, that the cycle one. If there was no cycle, every animal would have been sold for the double price. Because there can be cycles, only one animal per cycle wouldn't have the full cost they should be sold for. So like I can show you my code for this. So yeah, K stores the number of in edges. This is the vector which stores the edges. After that, yeah, I keep a queue and push all the animals which have the in edges as 0, and I use BFS to like push in the queue. After that, the cycle parts is left for so for each element I see if it has been covered already. If it hasn't been covered, I start a cycle from it. This stores the minimum, and I find the minimum, and once I found the minimum, I just push the vector. I start from the next element of that minimum and push it in the vector like this, and yeah, this is my code. Now I'll move on to the last problem of the contest. This is something like 3. Zero. So let's move on to the last question. Here's it is given that an array is given, and we can perform one of the operation where we select two integers L and R, and from L to R we multiply all the numbers in them, and make that element as one. I take the product of all the elements from L to R, and after that I take the sum of the array. So I want to maximize that sum. So this is the question. So how can I solve it? If you see in this question, mm, yeah. So if you see that most of the times you would say that taking all the elements of the array would be best because the product is the highest and the sum could be highest. In many cases, you can say yes, it would be true, but there are a lot of cases where there are lots of ones in between, and they might multiplying might decrease the sum. So basically basically the answer depends on the non one numbers, which are the numbers which are not equal to one. So if there are, let's consider if there are, let x be the count of a of I not equal to 1, not equal to 1. So if, let us consider if x is greater than equal to 20, it's just a number 20. So it means that the product of numbers is at least 2 powered by 20, because the minimum number is 2, right? Which is something like 10 near to 10 raised to power 6. So it means that like if I take an hmm, yeah it means that I should take all the numbers, right? Because it would maximize the sum. What is the maximum value of n? N is equal to 10 raised to power 5. So leaving out any of the numbers among these, all these numbers is not logical for me, right? Leaving any of the numbers which is not equal to a of I, sorry, not equal to 1. So leaving any of this number would decrease the overall sum. Because consider I have taken some numbers among them. Like consider that I have taken some 19 numbers, and the product is 2 powered by 19. It is the minimum product that could be in this array. And consider that all the numbers are 1 except one number is 2 in the end, right? So if I take these are the first 19 numbers. So if I take take this product and add all these, so what would be the sum? 2 powered by 19 plus 10 powered by 5 minus 2 plus 2, something like this. So which is 2 powered by 19 plus 10 raised to power 5. But if I take this 2, it would be 2 powered by 20, which is greater than this. That's why I took the limit 20. I can take the limit less than 20 also. Basically, it depends on this only, the length of the array, this limit. I could have taken 10 raised to power 17, I guess that would also have been fine. So, to be safe, I have taken x is greater than equal to 20. So if x is greater than equal to 20, we have to take all the numbers. We can't leave out any of the numbers. Basically, this was the worst case scenario in this. That's why I've taken it, and it also doesn't suffice. So if x is less than equal to 20, I can still apply some brute force algorithm, right? So what can I do is, obviously, if I have to take a product, I have to take I have to take a range L to R. It has to start and end at a non-one number, the number which is not equal to 1. Because like consider that the numbers were something like this: 2 3 2 1 1. So obviously it is logical to take this range. If I take this to this is not logical because product doesn't increase but the sum decreases. So it is logical that at the end the number is not equal to 1. Because if I take any one, it means that my total sum is decreasing. So what I can do is I can apply brute force. I can take the pair of all the numbers. So x is less than equal to 20. So there are less than equal to 20 numbers, which are less than 20 numbers, which are greater not equal to 1. So I can take every pair of these numbers and I can take the product in between and I can check the sum. So I can just apply the brute force and can take the maximum sum, and accordingly I can just take the range of the numbers. So the algorithm is quite simple. I can show you my code. So I have taken prefix sum just to easily calculate the sum. This factor stores all the indexes where the number is not equal to 1. So if x is greater than equal to 20, what I do is I take the first element of this vector and the last element of this vector. I take the first and last because the like one after the last element and before the first element don't matter. And if it is less than 20, I take this is basically the maximum sum. So I take the range as L equal to 1, R equal to 1 initially. I make two for loops. Here G is also the current product because I basically keep on multiplying the numbers to take the product. So I just take the non-one numbers as in the product because ones are useless for me for the product. So if G is greater than 1e6, basically the size of the array is 1e5. So to be safe, I have taken G is greater than 1e6. If it is the product exceeds 1e6, it means that it doesn't matter after that. I have to take the full range because the product is exceeding the length of the array. So I just take the first and last element. It is same as the previous case only. Basically, the if product exceeds the length of the array, in that condition, this is true. I could have taken the other condition rather than taking this. The product condition is better. So if it is not true, then I just see if it is greater than equal to max, the new number, pre of n minus pre of, this is basically calculation of sum. This is the implementation of calculation of sum, and I can just take the ranges, and this is the approach. So thank you. I guess we are done with all the solutions. So yeah, do join our Discord channel. Most of the time, daily contest discussions are held live on the Discord channel. So you can join our Discord channel given in the description. So thank you for attending.